What it is. Also, just need to classes which are today.
Looks like some blood cells stuff.
At one. Okay, so last lecture we started with chapter 4. Anyways, regarding the examination, we're done with it. The things that they are related to the exam are chapters 1 and 2. Okay, 3 is not included. We said that our objective in chapter 4 is to deal with higher order differential equation. Now we cannot start just by solving higher order differential equation. We need to understand some steps from it, some concepts. And that our main objectives are to understand what we mean by boundary values problem. Already talked about it, and we said that it means that we are given, instead of initial conditions, we are given values of the function at the boundaries. If x between a and b, we are going to get at a and b. And we need also to talk about the fundamental set of solutions. What we did previously, we talked about initial value problem when it has a unique solution. We said that if what we have before y prime are continuous and f x is also continuous, then it has unique solution, which is not the case for boundary value problems. Boundary value problems, they can have unique solution, no solution, or more than one solution. Then we started talking about homogeneous equation. We said that homogeneous equation, it means that differential equation equal to what? Equal to 0. If the order of differential equation is n, we should have n linearly independent solution, and this solution, the general solution, it will be a linear combination of them. How do we determine whether it's linearly dependent solution or linearly independent? It means that how do we determine whether we can use it as fundamental set of solution or not? We need to find something known as Wronskian. The Wronskian is like determinant. And if the Wronskian is not 0, then it is linearly independent, so it's fundamental set of solution. And if it is equal to 0, then it's linearly dependent. So we talked also about determinant 2 by 2 matrix, how we do it. It's the main diagonal minus the second diagonal. We talked also about the determinant 3 by 3 matrix. So this is the form of n order linear ordinary differential equation. Means that it's equal to what? Equal to 0, and these are examples of. We said that solution of n is linear combination of all solutions. Okay, any questions about what we discussed before? It's said that if we have second order, we should have 2 independent solutions. If we have 2 independent solutions, then the general solution that we are finding, or these 2 solutions, we say about them that it is fundamental set of solutions. In order to determine the linearity dependency or independency, what do we need to find? Yes, the Wronskian. How do we find the Wronskian? Let's say I have second order, so I have 2 functions. I will put the 2 functions as the first row. The derivative I stop here because I should get 2 by 2 matrix. If I have 3 functions or third order, I should do derivative first, then derivative second, because I need to reach 3 by 3 matrix. Okay. So to be linearly independent, we said that the Wronskian should be not 0. In this way, it will be linearly independent. Otherwise, if it's equal to 0, it will be linearly dependent. If it is linearly independent and the number of it is same as the number of the order, what do we call it? Fundamental set of solution. Okay, and how do we write the general solution for the homogeneousness? We write it this way. These ones, they were discussed last section. Now, for today's section, what we will do is solve, because we did not solve the examples of one fundamental set of solution. After we finish this one, we'll talk about the non-homogeneous part, and after it, we'll consider second order equation, we have one of its solutions, and how can we find the second solution for it? And we will be done with this, with these two sections. Already last section, we solved this example. We gave this example, y w prime plus y equals 0. We are giving you y1 equals sine x, y2 equals sine x. Logic with this one, it should have how many linearly independent solutions? 2. So if these two solutions are linearly independent, what do we call them? Fundamental set. And how do we write the solution? C1 times the first plus C2 times the second. The rascal of it was -1. So not 0. It means that linearly independent. Then it is fundamental set of solutions because we have two independent solutions and it is second order. So we can write the general solution as C1 sine x plus C2 sine x. But it doesn't mean that every time it's linearly independent, it will be fundamental set. Suppose that I have one order 100 and I'm giving you two solutions, they are independent. Can I consider them as fundamental? Why? Because I need how many? 100. Okay, miss? What we will do now, let's try this one. We are given here three solutions for what's the order of this one? Third order and homogeneous. So we need to prove that this one, these set of solutions form a fundamental set of solutions, and we need to write the general solution. Can we start with the determinant that we will find here? It will be 2 by 2 or 3 by 3. Why? Because third order and three solutions. What's the derivative of EAX? EAX. So E2X, it becomes 2E2X, and E3X, it becomes 3E3X. So how many functions do we have here, miss?
3.
So the first step, we will find the RASC. Here, what do we put, miss? Then derivative, first derivative. So here we will put first derivative. And here we will put the second derivative. Why do we stop here, miss? We stopped just one minus one of the order that we have, okay? Or as John is saying, to get the same number of rows as number of columns. Okay, how do we find this determinant? Let's find it here. Okay, we'll find it in details. EX into X was here and here E3X. We say we got plus, minus, plus, right, miss? So EX into something minus E2X into something plus E3X into something. What should we cover for the first one, miss?
Yes.
So we will cover always the first row is covered. Here we cover this one, the first column. So we are left with 2e, 2x, 3e, 3x, 4e, 2x, and here 9e, 3x. Right, miss?
If not, the example, just try to. That's
Yeah. I hear because I'm this. Done with the first. Now e to x, we need to cover the column of it. When we cover the column of it, miss, what are we left with? Ex here, 3e, 3x, and here 9e, 3x. Is it clear so far, miss? Clear, guys? معي عبد الرحمن. Okay. Now, what should we cover, Abd al-Rahman? Third, what are we left with? Ex, here Ex, 2e, 2x, and 4e, 2x. Now, instead of determinant of 3 by 3 matrix, we broke it up to get determinant of 2 by 2 matrix. So this one, the determinant of it is equal to what? AD minus BC. This one, AD minus BC, AD minus BC. So the first one, EX into AD minus BEC, 2E 2X times 9, it means that 18, E2X, E3X minus 12, right, miss? 12 E2X, E3X. Okay, the second one minus E2X, 9E4X minus 3E4X. And the last one plus E3X, 4E3X minus 2E3. Now, how did we get the 3x and 4x here? What do we do for these ones? Why do we need to add? Because the tab, we are using EA. We are using this one. Any question? Okay, what will we get now? So EX, 18E5 minus 12, 6E5X multiplied by X, 6E6X, right? The second one, 9 minus 3, 6. So minus 6E here. And here, 4 minus 2, 2. So plus 2E6X. These two ones are cancelled together. What did we get, miss? 2E6X. Is this one equal to 0? So what can we use, miss? Linearly independent. Again, LI is abbreviation of a initialism of linearly independent. Do we have any questions, miss? Okay, what can we do, miss? How many solutions do we have here? 3. And what's the order of our differential equation? It was 3, right? So what can we use now? They are linearly independent. The order is 3. Their number is 3. It means that this forms a fundamental set of solutions. How do we write our general solution now? So what can we say? EX, E2X, E3X. Their number is how many? 3/4 fundamental of solution for the given ODE of which order? Of order 3. So what's the general solution is? Y equal C1 times the first solution plus C2 times the second solution plus C3 times the third solution. This is regarding the homogeneous ones. So again, let's summarize. We have an nth order linear differential equation. We should have an independent solution if it's homogeneous, right? Now, to be linearly independent or to make sure that you are linearly independent, we will find the Ramsden. The Ramsden is equal to 0 dependent, not equal to 0 linearly independent. Their number is n, the order is n, linearly independent. This is fundamental set, and we can write the solution as C1 times the first plus C2 times the second, and so on. We're done with the homogeneous part. Now, non-homogeneous equation. Non-homogeneous equation, it's still an ODE, but after the equal, instead of having 0, we can have 1, we can have x, we can have EX, we can have patient x, or whatever. Okay, so we have a differential equation. It's equal to what? Instead of equal to 0, it's equal to something, number or function. And it's the number that we have on both function. It means that what we have after the equal is constant. How do we find the solution? It's very easy. We will divide it into two parts. So we have non-homogeneous equation. We will divide it as homogeneous and another part. The homogeneous part is the same solution as the homogeneous equation. What do we need also? Particular solution. Already the solution of the homogeneous part, we have it. Later on, we will learn how to find it, but at this moment, it would be given. We will also find a particular solution, and then the general solution, it will be this one that is here. Is the solution of the homogeneous, right? Using the Ramsden, exactly. And YP is the particular solution. Now, if you look here, this part, it contains constant. YP, it doesn't contain constant. Okay, it's a particular solution. So does it contain constant? So we don't have constant. Now, how do we find YP? How do we find the general solution? At this moment, we will not learn it. YP will learn it in 4.4 and 4.6. And this one, the general solution, will learn it in 4.3. But at this moment, everything will be given and we will write the solution. Okay, miss? Any questions? So again, non-homogeneous ordinary differential equation, it means that after the equal, we don't have 0. The solution, it will be the general solution of the homogeneous plus a particular solution. Any questions, miss, before we give an example? Regarding the previous examination, I remember that in the solving session, I saw this question. Do you have any questions about the previous examination? Okay, anyways, we can often question. Here's an example. We are given a third order differential equation equal to what? 3x. So this one is not zero. What can we say about it? Non-homogeneous. So the solution, it will be solution of the general one, which we found and which we solved in the previous example, plus particular solution. And already particular solution, look at it here, it's given, right? So all what we need to do is just add them up, add the homogeneous part to the particular solution. Again, here everything is given, but later on in section 4.4, we will learn how to find that. We will learn how to find the general and how we find the particular solution. So this one is solution of the homogeneous, and this one is the particular. Now, sometimes, yes.
For the equation there, they switched it. It was 11 over 12x, and then now 11 over 12x.
Plus 11 over 2x. Okay, I think this is the one that is correct. 11 over 12x minus half. We can try it anyways. This one is the correct one. So minus 11 over 2. So we will copy just this one is the correct one. Here, g of x is equal to 3x. What if we have, after the equal, 3x plus tangent x plus e power x? So we have three different functions that they are not related to each. It means that how many particular solutions we will have?
Yeah.
yp1, yp2, and yp. Okay. So if we have more than one particular solution, we will have all the particular solutions as one particular solution. So we will put it yp1 plus yp2 till y. I will give you an example here just to understand that. If you look, this is the particular solution. This is the particular solution, and this is a particular solution. So all particular solutions, we will add them up, and we will put the general solution plus the particular solution. Okay, Miss? Do we have any questions, Miss? How do we know that we will have three particular solutions? Polynomial, exponential, And this exponential is different from this exponential. So we have three functions. As if we have three functions, so we need three particular solutions. Now, this slide exactly will go in details in section 4.4. Okay, so just like we will add also the particular solution. Do we have any questions so far? Yes.
So you solve it as a particular solution
Each part has particular solution. Yes.
by itself, and then you add it.
Yes. Why? Because the particular solution is not beginner. You will find it. How do you find it? Usually, the particular solution, if it's linear with constant coefficient, let's say this one. This one is totally independent on this one, not related at all. And here we have e power 2x, here we have e power x, so they are not related. So we can divide it into three blocks. Each block will give us a particular solution that looks like it. So if you look at this one, we got a particular solution similar to it, right? Here, e2x related to e2x. And here we got xex related to this one. So the particular solution, usually it's related to the function that is given. Now we'll start solving, but we'll not start solving from scratch. We are given a second order linear differential equation written in standard form. Again, what do you mean by standard form? Before the y double prime, what we have? 1. Okay? We are given one of the solutions. Now you will tell me, why should they give us one solution only and not the second solution? Later on in chapter 6, we will learn a method when the method that we are solving, we know that it has two solutions, but it gives us only one solution. So how do we find the second solution? We call it reduction. Another way is sometimes we do, let's say, a program or algorithm to get a solution. The algorithm will reveal only one solution. So the second solution, we can find it using reduction. So to apply reduction of order, make sure that you write this one in standard form. It means that before y double prime, what should we have? G1. Then you have a solution. Y1 is a solution. You will write the second solution as y1 e power negative p of x. E power negative p of x, it reminds us of the integrating factor, but the integrating factor there, it was plus. Here it's what? Negative, and we will divide by y1. So y2, y1, here we will put y1 squared dx, y1 is given, and here e minus pe. Then what can we deduce? After that, what can we deduce? Y is equal C1 Y1 plus 2Y2. It will be our what, miss? Our general solution. Okay, miss? This method, we can just apply it in one case. If we know one of the solutions and we need to find the second solution. But if we know none of the solutions, we cannot use it. You write the formula. We'll put an example, we'll do it in details on the board, and then we'll choose one of the examples from the practice exercises. You will do it in pairs while I'm taking it. Any questions? What I need from you to do is just to write that this is a solution of this one, and we need to find the second solution. I will zoom in. Just write the question at this moment, and we will solve it in BB. So we are given this differential equation, and we are given a solution for it. So y1 equal x squared is given as a solution for x squared y double prime minus 3xy prime plus 4y. Let's write equation is y x squared y double prime minus 3xy prime plus or minus plus 4y equal to 0. Y1 is given as x squared. Find the second solution. Find the general solution. Of course, it's a second order. The general solution, it will be C1 times Y1 plus C2 times Y2. Okay, the first step, we look at this one. Is it given in standard form? Okay, so let's write it in standard. So step number 1, standard. How do we write the standard form? We should be giving you the x is possible so that we can divide by x. What would we get after dividing? Y double prime minus 3 over x y prime plus 4 over x squared y equal to 0. What we care about is everything before y prime. This one, it will be what, miss? Out. Okay, everything including the negative. Do we have any questions so far, miss? Please write it down and think about the next step. Put it in the formulas. This lecture is very important because we will learn how to solve. So next Tuesday is the exam. Thursday's lecture is very important because we will learn it how to solve. Is any of you traveling to Thursday? The next step now, we will write the formula. Y2 is equal Y1 e power negative PBF over Y1. Y1 is what, meant squared was, right? E power negative Y1 squared, it is x squared squared. What was P, miss? Negative 3 over x. Any questions so far? We cannot start integrating before simplifying. Okay, so we will try to simplify as much as possible. What will we get here? X squared squared is x4, and here we will get e 3 over x dx. This one is before the integral. This one is inside the integral. We cannot cancel something from inside and something from outside unless it's what is here. Okay, miss? Continue this one, miss. Let's continue. Did you finish writing from the board? What will we get now, miss? Y2 is equal x squared E3 then x. I did not put the absolute value because x is positive. Okay, miss? Now E and x, we will not keep them together. We will try to simplify it a little bit. E have real and x. Do we still remember how we write before? Yes, and so apply it here. What would be that? X squared, x cubed over x squared dx. So we will get x squared 1 over x dx. The second solution, we do not put a constant with it. Let x. Why didn't again I put the absolute value? Because x is positive. So this one is y2. We will put it in a box. In order to write our general solution exactly. Do we have any questions? Okay, so we found here y2. It means that we're done with part A now. In part B, they are asking us to find the general solution. So what would be the general solution? Part B, y equals d1 by 1 plus d2y, which is d1 x squared plus d2 x squared ln x, and this will be our final answer. Any questions, miss? Do we have any questions? Okay, let's choose an example. Can we try this one? Or we can try. Or we can try this one. Or this one. I will zoom in. We are given one solution. Are we okay? Are we able to see it clearly? Please. Do one of them and then we will do a discussion. Each two together, let's start with. I will take it and then give you. Miss, the first step, write in standard form, right, miss?
Question 9. Is it power
Power 4.
4?
This one is x power 4. And first, please go to the notes, practice. So this is a good thing to practice. Here, here, Abdelaziz is not here, Shams is not here, Abdurrahman is here, Muayyad here, Muay not here, Sultan not here, Abdullah Mansuri is here, Dilshad is here, Ismail here, Abu Zaid here, Amro is here, Shani here, Ali here, and Ahmad is here. Okay, so we need to write it in standard form, right? Premise, when we write it in standard form, P it will be negative 7 over x, right, Miss? Did all of us get P in this way? So E power negative P dx is equal to what? E power 7 over x dx, which is E power 7 ln x, which is x power 7. Did all of us get it as x power 7?
Yes.
Then what will be y2 now? Y2 is equal x power 4, x power 7 over x power 4 power 2 is x power 8 dx. So we will get it as x4 ln x. Of course, here we should be informed that x is possible. Did all of us get the same answer for the first one? Now the second one, did we try solving it? By substitution, we should use it. Please start with it, Miss. Any questions? Do you have any questions? Okay. So we're done with the first three sections of chapter 4, which can be considered as introduction. We talked about boundary value problems, initial value problems. We talked about homogeneous, non-homogeneous. We talked about particular solution, general solution, fundamental set of solutions using Granskin. And we talked also about second order. If we have one of the solutions, how we find the second one. This is a previous examination. If we go to the solving session, the subjective part, almost all of them they were solved, except I think for the homogeneous. We will go through the MCQs. Again, we cannot consider this one as a sample for our exam. This is for practice. Our exam will not contain MCQs. Okay, miss? So let's start with the first one. Every differential equation has a solution. Is that true? It's now we need to check which of these functions are separable. What do you mean by separable? Exactly. We can separate them into two boxes. X only and under multiplication, right? Let's look at this first one. Let xy. Are we able to do it? Xy minus 2. Now let's check this one. Can we write it as e minus 3y?
Yes.
But this one is separate. Miss, maybe it's not given as separable in the beginning. We are able to, okay, like this one. As it is in this way, it's not given as two boxes, but we are able to write it as two boxes. So this one is separable. Do we have any questions so far? Let's look at the second one. Is this one linear? Where's the problem of the linear? Y is power 6, right? Is it Bernoulli's equation? Doesn't it have the same form as Bernoulli's equation? How do we solve Bernoulli's equation? U equals y 1 minus n. What's n here? So we switch substitution. Y power negative. Okay, miss? So which one should we choose? Is it separable? Are we able to separate it? Let's look at this one. This is an initial value problem. The solution of, or the general solution of the differential equation is given. And we are given an initial value problem. We need to solve it. It means that we need to find A and B. How do we find A and B? What should we use now? We should use these ones. Can we start? So we are given this one as the general solution. And we are given initial condition. We need to find A and B. The solution of this objective part, I already included it in the solving session. So just add these ones to it. And please go through the solving session, because in the beginning of it, I recalled some a concept from calculus 2, which is partial fraction, which we will be using in the next chapter. I will not explain it again, because this one, it was given in calculus 2. Okay. Y of 0 is equal to 3. What will we get? So y of 0 equal 3. It means that AE power 0 plus BE power 0 equal 3. We got the first equation as A plus B equal to 3. That's equation number. Right, miss? But we have y prime. So what do we need to find also? Y prime is AE plus 2B equal x. Right, miss? Y prime at 0, it means that A plus 2B is equal to 0. How many equations did we get this? 2 equations. How many unknowns? 2 unknowns. We can solve it using any method. The easiest method is to solve it using the calculator. Please find the answer using the calculator. Find A and B using the calculator, miss. If you don't know how to use the calculator, please check with your colleague. Okay, A is 6 and B is -3, so I should choose this one. So, correct. So using the calculator, apply that A equals 6 and B is equal negative. You don't know to use the calculator. Because 2 equations. Any questions? All of us got the same answer using the calculator? Let's look now at this example. This one is the first order initial value problem. Y prime equal to f of xy. Y of x naught equal to y naught. This is a first order initial value. When can we say that this one it has a unique solution? We look at what means. We look at is it continuous? Then, if it's continuous, what do we find at y? Is it continuous? If both are continuous, it has unique. So here, this one is what our miss. Where is the interval that we are dealing with? X greater than 0, y greater than -1. If y greater than -1, we have problem in the radical. So F is continuous over this interval that is given. Now, what do we need to find as well, miss? Fy. Where's our apple in Fy? The x, right? Multiplied by something, so we copy it. What the derivative of radical 1 plus y? 1 over 2 radical 1 plus. Do we have problem in this interval, miss? Okay, so also it is continuous. What can we say? Does it have unique solution? Why? Because both of them are continuous when x is positive and y is greater than -1, in which it's initially given. Okay, miss? Do we have any questions? Please take your notes. Miss, in the exam, do not give more details than needed. Let's say I'm asking you, is it Bernoulli? I'm not saying solve it. I'm saying, is it Bernoulli? You will say yes or no. Okay? If I'm asking you, do not find the solution, do not continue. If I'm just asking you, find the solution and you reach the implicit form, I'm not expecting that you will do the explicit unless I'm asking you, find the explicit. So do not go and find the explicit unless it's what it's. Okay, miss?
Doctor, what's the difference between D and Y?
D. D and E.
D and
This is the avoidal acts. We don't care about the avoidal acts. Okay? We care just about F and F1, which is the avoidal one. Did I answer your question? Now let's look at this one. Give an example of a third order linear differential equation.
Wait.
Okay, y triplet prime minus y, let's say, equal 1. When we ask for an example, it doesn't mean that it should be complicated. Choose the easiest one, the simplest one. This one I solved it in detail in the solving session. This one is separable. How do we solve separableness? We will put y and dy on a side and x and dy on a side. Now, if you look here, because this one, I did not solve something related to this integral in class, I gave a hint to my students. But if I solved something similar, I will not give it as hint. Okay? This one, it was solved. Now, this one, it's linear. In order to solve it, what's the first step? Write in standard form. How do we write in standard form? If you look here, miss, I will not keep you confused. I told you x positive. So do I need absolute value for x?
No.
And do I need to think, can I divide by x or not? Already I'm telling you x not 0, you can divide by x, okay? Here also, I don't keep my students confused. I'm already asking for x. So here already I'm asking you for x. If I'm not asking, if you go back to the first one, yeah, I asked also for the explicit in the first one. So also in the first one, I asked for the explicit. One is also solved. Now this one, if you look at it, find an emphasis. But even if I told you find the general solution, it's okay. You can keep it as implicit. So this one, how do we check the exactness? We said that this one, we consider it as and this one as we will find my, and we will find x. If they are equal, it means that they are it's exact, and we can continue solving it. If they are not equal, it means that it's not exact. Okay, miss? This one also, it was solved. Now let's look at this one. This one is homogeneous. How do we show that it's homogeneous? We will take this one as and this one as What do we need to find? Anti-X, EY, and we need to find also anti-X. If you look here, it will be Tm, and here it will be Tm. Both of them are homogeneous of the same degree. It means that it is homogeneous. What's the substitution that we use when we have homogeneousness? Y equal Ux, and instead of dy, what should we put? UdX plus XD. While substituting, we need to expand after it, simplify, and then make it as what? Separable. So the U equation, U and X, it will be what means separable. We will solve U in terms of X, and then we will substitute U as Y. Do we have any questions? Okay, good luck for the exam and have a nice weekend. I will see you hopefully next.